Okay, got cut off on that last one there at the very end, but all I lacked finishing was just stating the answer. So as I was saying, that it is going to be continuous on your entire real number line. I didn't write the word real in here because again, there are no holes, jumps, gaps, that's going to interfere with the continuity of this graph. Okay. So still continuing with the same concept that we just finished discussing, but I don't have the graphs here on this one. So find the x values, if any, at which f is not continuous, and then of course state whether it's removable or non-removable. Now I'm just going to actually get the answers to these just based on what we know about certain types of functions, but again, you can always graph these functions in your calculator to kind of double check yourself. Now remember, when you're talking about continuity, it's always in reference to x. So like if you'll notice here, find the x values, okay? Now the first function that I have, this is a polynomial. A polynomial is always a continuous graph. There's never any interruption in the graph whatsoever. So when it says to find any x values at which the function is not continuous, there are none. So you would just state, like we've been stating, that this is continuous on entire real number line. So, I mean, it's just basically you just need to memorize and know if it's a polynomial, that will be your answer. Okay, the second one that I have is a rational function, which we discussed those just a few minutes ago. And when you're dealing with a rational function, you always have to be aware of what's happening with your denominator. So we said, okay, we've got to know what causes our denominator to equal 0. Now, the ones I looked at earlier, the expression I had in my denominator was a pretty basic one that we could just look at and tell. If you need to take your denominator and set it equal to 0 and solve it to see what's happening, then that's what you need to do. All right, so if I solve this, I'm going to use my square root property. Because I'm going to subtract 9, take square root of both sides. But when you take the square root of -9, remember that's going to give you plus or minus 3i. You're going to have an imaginary. When you're discussing numbers on your x-axis on your number line, that only involves real numbers. So like in this case, the only thing that's going to cause this to equal 0 is going to be imaginary. You don't see that on your coordinate system or on your coordinate plane. So this one, you don't have any real numbers. Of course, I've been specifying real number line that's going to cause you to equal 0. So this one's going to be continuous. Okay. All right, next one. Again, I'm dealing with one that's rational again. Okay, so just like before, I'm going to go to my denominator. And I'm going to set my denominator equal to 0. And I will need to factor this one in order to determine these values. Now to get the -3, then I'm going to have a minus 5 plus 2. So I get x equal 5 and x equal -2. Alright, so I know for sure those two x values, my graph is not going to be continuous there. But I do need to know why, because I have to determine removable or non-removable. You can go to your graph to help you out. But if you remember what I told you a while ago, let's just start with the 5. If the 5 only makes the denominator equal 0, then it's going to be a vertical asymptote. But if it causes numerator and denominator to equal 0, then it's going to be a hole in the graph. So actually 5 only causes your denominator. So that's going to be a vertical asymptote. And if it's a vertical asymptote, then it's going to be non-removable. Okay, same thing, or or you've got to check it the same way. I also have x equal -2. But see, -2 is going to cause my numerator to equal 0. So in that case, that's going to be a hole in the graph. So I'm going to say, let's just say non-removable. That's supposed to be a V. Non-removable discontinuity at x equal 5, but then I would have a removable discontinuity at x equal -2. Okay, so remember, this one is non-removable because it only makes my denominator equal 0, so it has to be a vertical asymptote. -2 is removable. It has to be a whole because it makes numerator and denominator both equal to 0. Okay, so next I have one here that has a trig function in it. Okay, of course, as far as the first term here, the 6, obviously there's not anything you have to worry about with that term. But the other second term containing sine. But now remember what I told you just a minute ago about sine and cosine. You know, it's just hill, valley, it goes up to 1 down to -1. When you're dealing with sine or cosine, either one, there's not any holes, jumps, gaps, no interruptions whatsoever. So if there's nothing to worry about with a 6, there's nothing to worry about with the sine, then this one's going to be continuous on your entire number line. Again, at any point in time with any of these, you know, graph them in your calculator if you want to just take a look at it.